Hello children, in today's session we are going to start a new chapter, that is refraction of light at a plane surfaces. Children, this light concept is not at all a new topic to you all. In the previous classes we learned about light, but not about a refraction of light. Rather, we studied about reflection of light, how a reflection of light takes place, and what is the image formation by a plane mirror and due to the reflection, and characteristics of the image formed by even spherical mirror also, which we discussed. But whereas in a 10th completely we are going to study about refraction of light at the plane surfaces, and after that we are going to even study about refraction of light at the curved surfaces, that is how refraction can take place in the case of lens also, which we are going to study. So now you think first of all, what actually refraction of light? Okay, you keep that refraction word aside. Once again let us recall what actually light is. Children, light is a form of energy which produces sensation of vision when it reaches our retina of eye. Then what can you say about refraction of light? See, dear children, when light travels from one transparent medium to another transparent medium, it's like might be like air to water, water to glass, or glass to water, water to air also. Refraction can occur. But dear children, in order to understand what actually refraction of light, we need to understand very important two terms, dear children. If you are okay with these two terms, dear children, entry topic means it will become very easy. You can enjoy what actually refraction of light. What are those two terms? One is denser medium, another one is rarer medium. But dear children, there is a small misconception here about rarer medium and a denser medium. What is that misconception? So many students, I am not saying that all, some students or some persons, they will think that denser medium means they think that having more density. Rarer medium means they will think having less density. But dear children, that density term itself is actually, more confused word it is actually. So it is not that much simple what we are talking about. Having more density means denser medium, having less density means what we can say rarer medium. It is not that actually. So whatever we are talking about density, children, that is purely about physical density. So it is also called as mass density. Means what? How can you define this physical density? It is defined as mass per volume. The best example to understand this, let us take here, dear children. So here is a container in which we have mixed water and kerosene. So obviously, dear children, what happens? Kerosene will be floating on the surface of the water, isn't it? Yes, obviously. What will happen, So water will take that bottom one, okay, whereas kerosene will be floating above the water. What is the reason? Yes, I think whatever is going in your mind is right. That is because kerosene density is less than that of the water density. So it's already very clear. It's very clear in the previous class which we learned. Whenever you mix two liquids with a different physical densities, mass densities, what happens? The liquid with the less density will be floating above the liquid of the more density. So here what can we say? Can we write like this here? Density of, try to understand here. So density of water is greater than that of the density of kerosene. Density of kerosene. Let me write here, shortcut I am writing. Density of kerosene. Which means what here, children, here? Water is more denser, kerosene is less denser. But dear children, strictly we are talking in terms of physical density only. Physical density only. Then in order to understand what is the denser medium, what is the rarer medium, children, we need to understand what actual optical density, very important. Means in terms of physical density, children, water is more denser, kerosene is less denser. Now we are going to discuss very important term, that is what actually optical density. Children, once if you can understand the difference between physical density and optical density, then the concept so called refraction will become very easy here. Very means very much easy. So here, dear children, once again I repeat here, physical density is a property of the medium. How can we measure? We can measure in terms of mass and volume. But what is optical density? how it can be measured? Based on optical density, how can you decide a medium is a denser and another medium is a rarer? Let us see, the children. See, purely optical density is defined in terms of speed of light. Very, very important. So, it is defined in terms of speed of light. So, based on speed of light, we can say what actually denser medium, what actually rarer medium. Teacher, let us take these two examples only. Let us take these two examples only. So, what is the speed of the light in water? Let us see once again. Children, in a water, light will travel with 2.25 into 10 power 8 meter per second. Children, so very, very important, we have to remember that. What is the speed of the light in a water, dear children? 2.25 into 10 power 8 meter per second. Then what about the same light when it travels, means with what velocity it can travel through the kerosene? Children, the speed of the light in a kerosene is approximately, it is 2.04 into 10 power 8 meter per second. So look at that. Try to observe that. Now you forget about physical density for a while. So now we are talking in terms of speed of light. So speed of light in water is 2.25 into 10 power 8 meter per second. Whereas the speed of light in kerosene is 2.04 into 10 power 8 meter per second. Now just you tell, in these two mediums, let us say it's water and it is kerosene, through which medium light is traveling faster? Of course, everyone can say that yes, it is water. And whereas in a kerosene, when compared with water, the speed of the light is less. Means here, children. So optical density means speed of light in a two mediums. If you can take here, in one medium it is high or more, in another medium it is less. Children, here water is said to be rarer medium, whereas kerosene is said to be denser medium. Means what way we are concluding, on what base we are concluding this? Yes, we are concluding this. We are defining denser medium and rarer medium based on speed of the light. So, if a speed of the light is more when you compare with other medium, that medium we can call it as a rarer medium. Very, very important. Whereas, when compared with a particular medium, if the speed of the light is less, then such medium we can call it as a denser medium. Now, dear children, look at here. Here in kerosene and water, which one is a rarer medium, which one is a denser medium? It's very clear that when compared with water, the speed of the light is less in kerosene. So, it is denser medium. But whereas, when compared with the kerosene, the speed of the light is more in water and it is called rarer medium. So, children, on what base? See here, optical density is completely discussed or defined in terms of speed of light only. The medium in which speed of the light is more. Speed of the light is means speed, what a light can travel faster when compared with other medium is called rarer medium. Whereas the medium in which light travels slower compared with another medium is called denser medium. So now, dear children, now you compare here. Here whose density is more in terms of physical density? No doubt about it, it is water. Try to understand, dear children. Here, very, very important. Here, water density is more. But whereas here, kerosene density is more. Try to understand. Children, two same mediums. We are not changing the mediums. But that's what I am saying, children. So, in a light chapter, whatever the density is called actually optical density. Is the optical density in terms of speed of light only. So, optical density is different and physical density is different. So, let me conclude once again here, children. So, when you consider the physical density, water has more density than kerosene. But whereas when you consider the optical density, that is the speed of the light, when you consider what here, water is a rarer medium, whereas kerosene is a denser medium. So, what is a denser medium? The medium in which light travels slower when compared to other medium is called denser medium. What is a rarer medium? The medium in which light travels faster when you compare the other medium is called rarer medium. Okay children, hope this concept is very clear what actually rarer medium and denser medium. Now we will see. So it's clear about what actually denser medium and rarer medium. Now we are going to get into the actual topic called refraction of light. Let us see once again. Means now we'll try to see what actually refraction of light, which means what happens when light travels from one medium to another medium, we will see. Fine. But before that, children, so here we need to know the speed of the light in a different medium. It's very, very important. Just can note down this. Children, speed of the light in a different mediums, let us see. So here air or vacuum, almost the speed of the light is same in both. That is 3 into 10 power 8 meter per second. Whereas in water it is, what is the speed of the light in water? It is 2.25 into 10 power 8 meter per second. Whereas the speed of the light in a glass is 2 into 10 power 8 meter per second. And whereas in a diamond, the speed of the light is approximately, it is 1.42 into 10 power 8 meter per second. Now dear children, here I have a small question here. My question is that here, let me take here glass. Children, my question is that, is glass denser medium or rarer medium? Children, just pause the video, think and comment your answer. Just comment you have an answer. So here, is glass rarer medium or a denser medium? Children, only one medium is given. We cannot say that either it is rarer or denser unless you compare. Means, for example, when compare with a diamond, children. So when compare with a diamond, the speed of the light is more in glass. So when compare with a diamond, the speed of the light is more in a glass. So it behaves like a rarer medium. But whereas when you compare with water, the speed of the light is less in a glass. So it behaves like a denser medium. So what I mean to say is that a medium can be rarer or a denser. It depends on other medium with what you are going to compare. The best example is this only. So glass can be rarer and denser. What way we are deciding? Just we are deciding based on the speed of the light. So what is the speed of the light in a glass and what is the speed of the light in a other medium? So once you can understand this point, children, next topics will become very easy. Now we will see what happens when light travels from one transparent medium to another transparent medium. Just have a look here. Case 1. First, we will see case 1 where light is traveling from one medium to another medium. Look at here. So in case 1, light is moving from rarer to denser. Children, it's very, very important. So light is moving from rarer to denser medium. Whereas in a second case, light is moving from denser to rarer medium. Now let us see what happens when light moves from rarer to denser, what is going to happen, and what is going to happen when it travels from denser to rarer. So we'll teach you. So look at here. So here light is moving from air to water. Acha, what is the speed of the light in air, children? Let us recall once again. It is 3 into 10 power 8 meter per second. Whereas here it is 2.25 into 10 power 8 meter per second. So definitely here air is a rarer medium and water is a denser medium. So this is a case where light is moving from air to water, that is rarer to denser. Children, we know that in air, that is in a rarer medium, light is traveling faster. But whereas when it enters into the denser medium, what happens? Is it like a slows down or it will become speeds up? No, it's not that. So whenever light moves from air to water, that is rarer to denser medium, children, the light will become, it slows down. It's very, very important. So light always travels with a less speed in a denser medium than in a rarer medium. So whenever light moves from rarer to denser medium, it slows down, due to which, dear children, it moves towards the normal. So this is refracted ray. Children, it is, let us say here, Mn is a normal Mn is a normal, and here xy is a boundary between the two medium, that is interface, and such a that here is the angle between incident ray and the normal drawn is called angle of incidence, whereas the angle between refracted ray and the normal is called angle of refraction. Children, if you can observe here, as it is moving from rarer to denser medium, but observe these angles, angle of incidence is greater than the angle of refraction. Very, very important. So whenever light moves from rarer to denser medium, the light bends towards the normal, and at the same time angle of incidence is greater than the critical angle. Now let us see the second case where light is moving from water to air, that is the speed of the light in water is 2.25 into 10 power 8 meter per second, which means what here? Water is a denser medium than than air actually. Now look at here. So this is incident ray, how the light ray is incidenting, and it is a point of incidence, and as usual it is a M, N is a normal drawn, and XY is the interface between the two mediums. Now dear children, as the light is moving from denser to rarer medium, it speeds up, because we know that in a rarer medium light travels faster, and air is a rarer medium when compared with the water. So whenever light moves from denser medium to rarer medium, light speeds up, due to which it moves away from the normal like this, straight line. So it will move like this. So here you make it one doubt. What is this dotted line, dear children? It is actually virginal path of the light ray, which means what? If there was no second medium, light would have traveled along in a straight line path actually. Okay, fine. So here what is happening? Light is moving away from the normal. Light is moving away from the normal. And this is angle of incidence, and this is going to be angle of refraction. But in this case, dear children, angle of incidence is less than that of the angle of refraction. Angle of refraction. So this is what actually happened when light travels from rarer to denser medium, denser to rarer medium. But dear children, in these two cases, one common thing we can observe, one common thing we can notice. What is that? Light is changing its path. Either it is moving rarer to denser or denser to rarer. Light is changing path. I mean, light is bending. Where it is bending? At the interface between the two mediums. In these two cases, light is not going like a straight line path. Rather, it is bending. Children, this phenomena of light only we can call it as a refraction. So simple it is. So what actually refraction is? Let us make a statement. Let us make a definition. It's very important to write in exam, right? So what is a refraction of light? So how to define it? Children, when light travels from one transparent medium to another transparent medium, it is bending at the interface between the two mediums. This phenomena of light only we can call it as a refraction of light. That is fine. Then next question will come to our mind. What is the cause of the refraction? Children, it's a very, very, very important examination point of view. What is the cause of the refraction of light? So if you want to understand that, 1 second let us recall. What actually refraction? Refraction is simply the bending of light when it is moving from one transparent medium to another transparent medium. Now let us question, why the light ray is bending? Why the light ray is bending? See, it might be towards the normal or away from the normal. Why it is bending? Because it is deviating. Of course, the deviation we can call it as bending. Why it is deviated? Because the change in speed. So because the speed of the light is changing from one medium to another medium, that's what light is bending. That only we can call it the refraction of light. So in exam, if they'll ask you what is the cause of the refraction, what we should write? We should write the change in speed of the light is a reason for the refraction of light. So this is how refraction can occur. Now we will see, dear children, during the refraction, what will change is very, very important. Very, very important. Means in exam, they'll give like this, like 3 to 4 words will be given, like a velocity, or wavelength, or frequency, amplitude, or intensity will be given. They'll ask you which of the following will change during the refraction of light. It's very, very important. So children, now we will see. So whether wavelength will change or not, frequency will change or not. So during the refraction, what will change? It's very, very, very important. Children, it's very clear that the first point we can make a conclusion. This one, first point, during the refraction. So during refraction, during refraction. Let us see. Dear children, it's very clear that whenever light moves from one transparent medium to other transparent medium, what will happen? Either light may speeds up or slows down, which means what? The speed of the light changes. So because of that only refraction is occurring, right? So definitely during the refraction, speed will change. Very important. Speed will change. Children, the second term is very important. Very means very much important. What is that second term? Is all about frequency. So in a textbooks also it is given that, children. What is that? Frequency remains constant during the refraction. Of course, we also will tell that. Of course, it's true actually. Frequency remains constant. Frequency does not change. Here speed will change. But whatever now I am going to discuss is actually about a frequency. Children, very important this is. Here the question is that why frequency does not change? Why frequency does not change? Of course, we will read, we may by heart and read. It's not that. Children, physics is not like, it's a by hearting. When you try to by heart the concept, it will become tough. It is not that. We have to feel that content. We have to feel that content. Means that visualization is very important. Visualization, the picture should come to your mind actually. So let us recall once again what actually frequency. Yes, frequency is the number of waves passing in a second is called frequency. So that definition is very important to understand frequency remains constant during refraction. The best example let me take here. So for example, let us take so it might be from denser to rarer. Let us take one more case, rarer to denser. My point is that, for example, here like this, like 3 light rays are coming like this. 3 light rays like this. So when they enter into the denser medium, obviously they'll move away from the normal like this. Okay, no problem. They will move away from the normal. Okay, fine. But whereas here also let us take 3 light rays only like this. So as they are moving from rarer to denser medium, okay, they'll bend towards the normal. That is fine. Okay, it's not a problem. So now let us recall once again the frequency definition. The number of waves passing per second. For example, dear children, here how many number of waves are passing? Of course, 3 waves are passing. But whereas here, same number of waves are passing, right? Means waves are not observed here. That energy may differ, but not number of waves. So here also, number of waves in rarer medium are same, and number of waves in a denser medium is same. Means the number of waves which are passing in a denser medium and rarer medium are same. That number of waves only we can call it as actually frequency. So during the refraction, dear children, frequency remains constant. So very important. Children, frequency is a characteristic property of the source of light. Means what? As long as the source of light is same, frequency remains constant. You have to change the source of light in order to change the frequency. Otherwise, for a given source of light, frequency remains constant. So for our Earth, the natural like a source of light is sun. So we are not going to change sun, right? So that's what we can say, that during a refraction, frequency remains constant. Frequency remains very important. During refraction, frequency remains constant. Frequency remains constant. Okay, that's fine. Now second point is what actually wavelength. So here question comes here, whether wavelength will change or not. It remains constant. So for that, let us recall this. V is equal to frequency into wavelength, lambda. So we know that during a refraction, frequency remains constant. As the frequency remains constant, dear children, V is proportional to the lambda, which means what? When speed increases, wavelength increases. Speed decreases, wavelength decreases. So the second thing what will change during the refraction? Wavelength. And the third one is that, dear children, third one is intensity of light. Third one is intensity of light. Intensity of light actually. Dear children, here then how to understand this intensity of light? Children, if you think practically, let us talk practically. Think practically. So here is a boundary between the two mediums. So it might be rarer to denser, whatever it may be. Just it is a boundary between the two mediums. For suppose, dear children, here one light ray is coming like this. So it is a normal. Let us think this light is coming with a 100% energy. The energy of this light ray is 100%. So this light ray is going to get refracted, right? Okay. it is going to get refracted. Dear children, so the energy of this ray of light, let us, it might be like 97%. Children, I am not measuring, it may not be perfect values, just to make you to understand, just we are taking a small values here. So then we will get one doubt. So here this is 100% of energy, okay, 97%. What about that remaining 3%? Dear children, here partial reflection can occur, partial reflection can occur, means you can take any boundary, dear children. Some amount of light, means partial reflection will be there. Some amount of light gets reflected. So it might be, for example, 2%. But still we will get one doubt. What is that? It is 100%. It's a 97% light is getting refracted. 2% is getting reflected. 97 plus 2. It is how much it is? Still 99. What about that 1%? Dear children, that light energy may get absorbed here. Light is absorbed. It's very, very, very important to understand. Very, very important. Very, very important. So here, now look at here. Is the energy, intensity is what, dear children? The energy per unit area we can calculate. That energy only we can take here. So is it changing or not during the refraction? Yes, it is changing. Children, practically 100% light won't get refracted. What happened? Some partial reflection and a refraction and absorption will take place. Okay, dear children, fine. So during the refraction, speed will change, wavelength will change, intensity also will change. But whereas the frequency of light remains constant. Why frequency of light remains constant, dear children? Because frequency is what actually number of waves per second. So either it is rarer to denser or denser to rarer. Number of waves won't change. And moreover, frequency of light is a characteristic property of the source of the light. As long as the source of the light is same, the frequency remains constant. Now, dear children, very, very, very important. We are going to see a no refraction cases. No refraction case. Which means what, dear children? It is not compulsory. See, so far we discussed when light travels from one transparent medium to another transparent medium, what is happening? Refraction is taking place. But dear children, it is not in all cases. It is not in all cases. So let us see that. Case 1. So it's very, very, very important. Case 1. So what is that? So here, to understand this, here is boundary between the two mediums. Children, it might be from rarer to denser or denser to rarer, whatever it may be. So here light is traveling from one transparent medium to another transparent medium. Now let us take, here is a normal drawn. Normal run. Now see, if the light is passing along the normal, children, this only we can call the normal incidence actually. Normal incidence. So light is incidenting perpendicular to the interface between two mediums. If this is interface between two mediums, light is exactly incidenting perpendicular to this interface. Perpendicular interface. Children, in this case, what is the angle of incidence? What is the angle of incidence? So here generally we think, yes, it is this one, it is a 90 degrees. So we think that it is a angle of incidence 90 degrees. No, it is wrong. See, the light ray is going along the normal, it is incidenting normally, that is perpendicular to the interface. But what is the angle of incidence, dear children? The angle between normal and incident ray is called actually angle of incidence. But here, light ray is going along the normal, means there is no angle between these two. So here, what is the angle of incidence here? Angle of incidence in this case is 0. That is fine. Then what will happen, whenever light incidents normal to the interface, dear children, it will go undeviated. Very, very, very important. It will go undeviated. Then what is the angle of refraction in this case? Your angle of refraction also is 0 only. Children, whenever light incidents normal to the interface between the two medium, it might be rarer to denser, denser to rarer. What happens? Light will go undeviated, which means what? Refraction cannot occur. This is the first case. Now here, case 2. Okay, so we may think that, okay, only when light incidents normal to the interface only, light is not getting deviated, we will think. But let us see one more special case, dear children. Here is interface between the two mediums, X and Y. And here is a normal. Now by this time, light is not at all incidenting normally. So light is going like this. Means definitely there will be some angle of incidence. There will be some angle of incidence. And let it be this is a medium 1. This is medium 1. And here is medium 2. It is a medium 2. So, light is moving from one transparent medium to another transparent medium. But in a special case, what happens, light here generally what do we expect? We expect that after studying refraction of light, we expect that it may move towards the normal or away from the normal. But in this case, what is going to happen, this light ray will go in straight, which means what? Light is not at all getting deviated. So, this angle of refraction, so here angle of incidence equal to angle of refraction. What is happening here? Children, it is possible only when the let us say refractive index of the first medium is mu1. Children, next anyhow we are going to discuss refraction, what a refractive index in detail. So, let us think. So, refractive index of the medium 1 is a mu1 and the refractive index of second medium is a mu2. This happens only when the refractive index of the two mediums is same. Children, very important. Very important. So, there are the two cases where though light is going from one transparent medium to another transparent medium, refraction cannot occur. So, first case when light incidence normal to the interface between the two mediums, but whereas in the second case it is not a normal incidence, it is a what we can say certain what we can say some oblique incidence. It is called oblique incidence. But still light is not getting deviated. Why? What is the reason? Because in this case the refractive index of the first medium is equal to the refractive index of the second medium. So, then also what happens, dear children? Light ray won't get deviated. Okay, fine, just copy it. Now, we will discuss the very important thing is that loss of refraction. Loss of refraction is a very important examination point of view. Loss of refraction. Loss of refraction. Loss of refraction. Now, let us take a case, dear children, where light is moving from one transparent medium to another transparent medium. For suppose, here is, let us say, the interface between the two mediums such that it is a normal, okay, and let it be it is a denser or rarer medium, no problem, anything is okay, rarer medium, and here is a denser medium. Here is a denser medium, such a way that here light is incidenting like this. Light is incidenting. If there is no second medium, dear children, what would happen here? Light would have travelled like this along a straight line path. But as the light is moving from rarer medium to denser medium, it slows down, due to which what happens, dear children? It moves towards the normal. This light will move towards the normal. Now, let us try to show the angle of incidence and angle of refraction. So, this is angle of incidence and here is angle of refraction. Now, children, let us name it as a PQ is a incident ray, whereas RS is a refracted ray, MN is a normal drawn, and here this is what, dear children, it is O is a point of incidence. Now, let us see what is a first law of refraction. First law of refraction, dear children, PQ, that is incident ray, RS refracted ray, MN normal drawn, all will be lying in the same plane at a point of incidence. Very important, children. Incident ray, refracted ray, normal drawn, all will be lying in the same plane at a point of incidence. That is the first law of refraction. And here second law of refraction, children, it is very important. Very means very much important. The second law of refraction is a very important. Based on that, we are going to solve even numericals also. What is that, dear children? Here some angle of incidence is there, I value. For that, we can calculate sine value. Even here R value is there. For that also, we can calculate a sine value. So, what actually this second law of refraction will say is that the sine value of angle of incidence to the, that is the ratio of the sine of angle of incidence to the sine of angle of refraction is always constant. I repeat once again. The ratio of the sine of angle of incidence to the sine of angle of refraction is always constant. But conditions are applied here. What is that condition? The condition is that, children, here for a given pair of two mediums only. For a given pair of mediums, for a given pair of mediums only, this is a constant. For suppose, dear children, for suppose it is, let us take a water, it is a glass, it is a glass. So, dear children, for this water and a glass, for water and a glass, dear children, this always remains same. This always remains same, means whatever the, what we can say, angle of incidence or whatever may be the angle of refraction, the ratio is always remains constant. This is what actually second law of refraction. Children, here it is also called as Snell's law, very important. Snell's law of refraction. What is the Snell's law of refraction, dear children? So, Snell's law states that the ratio of angle of incidence to the angle of refraction always remains constant for a given pair of two mediums. For a given pair of two mediums, it always remains constant. But dear children, here, this here specialty is there. This constant is a very important. This constant is given actually a special name. This constant only we can call it as a refractive index. Very important. This only we can call it as a refractive index. Refractive index we will represent with a letter called mu, is a Greek letter. Refractive index. So, the ratio of sine of angle of incidence to sine of angle of refraction is always constant. That constant we can call it as a refractive index. But dear children, it is a refractive index. The light is moving from first medium to second medium. Then mathematically, how can we express Snell's law? Refractive index of second medium with respect to first medium is equal to, it is sine of angle of incidence to the sine of angle of refraction. So, this is called mathematical form of Snell's law. Children, it's very important. Sometimes they may ask you, state the Snell's law. Then you have to write the ratio of the sine of angle of incidence to the sine of angle of refraction is always remains constant for a given pair of two mediums. If they will ask you to write a mathematical expression, directly you can write mu is equal to, that is refractive index second medium with respect to first medium is equal to sine I by sine r. This is what actually Snell's law of refraction. Now, dear children, we will move to the refractive index. Very important. Now, we are going to discuss what actually refractive index. Dear children, what is the importance? First, we will learn what actually refractive index is, and we will see how to calculate the refractive index. Then, what is the importance of refractive index, dear children? In fact, dear children, refractive index will decide the whether medium is like optically denser or optically rarer. Means if mu value is more, the optical density is more. If a mu value is less, then optical density is going to be less. That is, it is going to become like a rarer medium. And after that, even we will discuss the factors which affecting the refractive index. So, first let us learn what actually refractive index is. Refractive index and its importance, its units, on which factors does it depend. Examination point of view, very important. Very means very much important. Dear children, so mathematically, refractive index is defined as, so it is symbol is mu. Here mu is equal to, it is defined as C by V. So it is defined as mu is equal to C by V. Then here we get one doubt. Here what is C, what is V, what is a mu? Of course, mu is obviously refractive index only. Children, what is C here? C is a speed of light in air or vacuum. In air or vacuum. But what about V, dear children? Here V is a speed of light in a medium. Here we get one doubt. Sir, what is this air and medium? Medium means what? Other than air, it might be kerosene, it might be water, it might be glass, it might be diamond, it might be any other other than air is actually we can take it as a medium only. So now let us see here. How can we define refractive index? Children, it is defined as a ratio of speed of the light in air to the speed of the light in a what we can say medium is called refractive index. In fact, dear children, this only we can call it as a absolute refractive index. Very important. Means the refractive index of the medium, when you compare with the what we can say air or a vacuum, that refractive index we can take it as a absolute refractive index. Now, dear children, then what are the units? What are the units of refractive index? Very important. Children, It is ratio between speed of light in a vacuum to the speed of the light in a medium. Means whether speed of the light in a vacuum or air or kerosene or whatever it may be, what are the units of speed, dear children? For the C, the units are meter per second. Then whatever this units for V, it is a meter per second only. Which means what, dear children? This will get cancelled. Means what? Refractive index has no unit. Children, it's very important. Very important. So refractive index has no units. And one more thing, dear children, very important thing is that refractive index is always greater than 1. It can never be less than 1, dear children. It can never be less than 1. What is the reason? Why a refractive index of medium is always greater than 1? Why it can never be less than? It's a very important question. Why it cannot be less than 1? Why it is always greater than? Because of this only. Children, we know that C is always greater than that of the V. So numerator, that is what? The speed of the light in vacuum is more. Children, light can travel, means with highest speed in a vacuum only. In no other medium light can travel faster. That's what? Numerator is always greater than the denominator. I repeat once again. Numerator is always greater than the denominator. That's what? Refractive index is always greater than 1. It can never be less than 1. It's very important. Okay, children, fine. What actually refractive index? It is the ratio between speed of the light in a vacuum to the speed of the light in a medium. And it has no units. And it is always greater than 1, and it can never be less than 1. It can never be less than 1. In exam, they'll ask you the question, why mu value can never be less than 1? So you have to write that. That is a numerator. That is the speed of the light in a vacuum is always greater than that of the any other medium. Okay, fine. And actually here, one more very important thing. What is that here? C is a constant. The speed of the light in a vacuum or air is always constant. So as C is a constant, children, mu is inversely proportional to the V. Mu is inversely proportional to V. That is what, children? The refractive index of the medium is inversely proportional to V. Which means what? More the refractive index, less the speed of the light. Less the speed of the light, which means what? More the refractive index. So let us see once again, children. For suppose here it is two mediums. It is a medium 1 and here is a medium 2. So let us say the refractive index of the medium 1 is a mu 1 and it is a mu 2. So that the speed of the light in this medium is V1 and the speed of the light in this medium is a V2. Then we can write like this. It is mu 1 by mu 2 is equal to V2 by V1. V2 by V1. Children, is a very important relation. So whenever the speed of the light in a two different mediums is given, we can calculate the ratio of the refractive indexes of that particular two mediums which we can calculate. So it is a inversely proportional. I repeat once again, children. Refractive index of the medium is inversely proportional to the speed of the light. Now we will see some values, what are refractive index of the what values of some mediums. Then we will get a more picture. Means we will get a more clarity. We will get a more clarity. Look at here, children. For suppose here, let us take here is air, is a medium, and let us take here is a water. Next for a glass as we will take, and here is a diamond. Let us take a diamond. So now let us take let us see the speeds. The speed of the light, let us see first. Speed of the light in these different mediums. Then we will see refractive index values also we will see. The speed of the light means is a meter per second which we are going to take, meter per second. In air it is 3 into 10 power 8, whereas through water it is 2.25 into 10 power 8. In a glass it is 2 into 10 power 8. Diamond it is 1.42 into 10 power 8. That's fine. Then what about refractive index? Air or vacuum? Children, air or vacuum, it is 1. Its value is 1. The refractive index of water is 4 by 3. It is also we can take as 1.33. The refractive index of the glass is 3 by 2 or it is 1.5. And diamond it is 2.42 approximately. Now children, now try to understand the values here. So as a refractive index value is increasing, what is happening? The speed of the light is decreasing. which means what, dear children? As the refractive index value is more, that medium behaves like a denser medium. If the refractive index is less, that particular medium behaves like a rarer medium. Children, means this means by knowing the refractive index value, dear children, what we will come to know that? Means we will come to know that how strongly refraction is going to occur. Means how strongly the light ray is going to bend. It might be towards the normal or away from the normal. So then how the questions will be asked in exam, let us see. Children, in exam they may give a question like this. The refractive index of, for example, diamond is 2.42. What does it mean? Or else the refractive index of glass is 1.5. What does it mean? Let us take, here is example. Example, teacher, look at here. So the refractive index of glass is 1.5. This statement is given. So what is the meaning of this statement? Means here it is given mu is equal to 1.5. So let us take this value, this formula let us take. So here mu is equal to C by V. In the place of mu you can write the value, that is 1.5 is equal to C by V. Children, this we can write it two ways. So we can write like this. We can write C is equal to 1.5 into V, or we can write V is equal to C by 1.5. Of course, anything is same, meaning is same only. So again I repeat, the refractive index of glass is 1.5. What does it mean? It means that, look at here, the speed of the light in air or vacuum is 1.5 times than that of the speed of the light in a glass. Here V is what? Children, here V is speed of light in a glass. The speed of light in a glass. Children, it's very, very important. So the refractive index of glass is 1.5. What does it mean? It means that, dear children, the speed of the light in a vacuum is 1.5 times greater than that of the speed of the light in a glass. Or you can say like this also you can tell. The speed of the light in a glass is 1.5 times less. Of course, both are same only, right? So saying C is equal to 1.5 times V is equal to V is equal to C by 1.5. So these kind of questions we can expect. So it is given refractive index of our diamond is a 2.42. What does it mean? It means that the speed of the light is 2.42 times greater, what we can say, in air than that of the speed of the light in diamond. So this is what actually meaning, and these kind of questions which we can expect. And children, even we can expect the numericals based on this. Let us see one second. So what type of numericals will be asked? Very simple numericals will be asked. So here example, let us see here. Example, if the speed of the light or speed of the light is given or mu is given, for example, children, the refractive index of the glass is given 1.5, let us take. Then what is the speed of the light in a glass? Children, it is given. The refractive index of the glass will be given. They will ask us to calculate the speed of the light in a glass. Let us see how. So here mu is given, that is 1.5. This we can write as a 3 by 2 also, no problem. And we know that C value always remains constant. Dear children, whether the value is given or not. So we have to remember this. 3 into 10 power 8 meter per second. Then V is the speed of the light in a glass, that to be calculated. Now let us take this formula, that is mu is equal to C by V. Now let us make V as a subject, that is V is equal to C by mu. Now let us substitute the values, that is V is equal to 3 into 10 power 8 by mu is equal to 3 by 2. 3 cancel. This denominator and denominator will become a numerator. That is V is equal to 2 into 10 power 8 meter per second. So children, this is how actually we can calculate. Even when V value is given, of course we can calculate the mu value. So based on this we can expect the numericals also. Fine, just copy it. Fine. Now dear children, we will discuss the relative refractive index, very, very important. So far whatever we discussed, the absolute refractive index. Children, don't get confused. Absolute refractive index is what actually? The refractive index of one medium with respect to air only. That is called absolute refractive index. Then what is the relative refractive index? Relative refractive index. So based on this also, we can expect 1 mark questions. Relative refractive index, which means what? The refractive index of one medium with respect to another medium is called actually relative refractive index. For example, dear children, for example, look at here, the refractive index of water with respect to glass. Let us take a glass. The children, here mu W is a refractive index of the water, whereas mu G is a refractive index of the glass. Then refractive index of water with respect to glass. How can we write? We can write like this: refractive index of water with respect to glass. This is how we can write. And this also can be written like this: refractive index of water by refractive index of glass. But teacher, don't forget that this is nothing but again with respect to air only. Don't forget it, with respect to air. So of course, if you write or not, it doesn't make a difference actually, because it's the absolute refractive index of the water by absolute refractive index of the glass actually. So what is the relative refractive index? So the relative refractive index of one medium with respect to another medium only we can call it as a relative refractive index. How can we calculate? Let us see detail. So this formula means how we can. Now, so they will ask you to calculate the refractive index of water with respect to glass. Children, we know the values actually. So mu W is equal to 3 by 2 and mu glass is equal to 4 by 3. Sorry, it is wrong. Mu W is 4 by 3 and mu glass is 3 by 2. Now what we have to calculate? Refractive index of water with respect to glass we are calculating. This can be written as mu W by it is mu G. Now let us substitute the values. It is 4 by 3 by 3 by 2. This is going to be 4 by 3 into 2 by 3. This is how much, children? 8 by 9. It is 8 by 9. This is what? 8 by 9 is a refractive index of water with respect to glass. But what is the refractive index of glass with respect to water? Do you think that it is same? Children, can you calculate what is the refractive index of glass with respect to water? Just pause the video and do it and comment your answer. What is the refractive index of glass with respect to water? Fine, got it? Now let us see here. So this can be written as mu G by mu W is equal to, so children, mu G is what actually? Refractive index of glass is 3 by 2. That is 3 by 2 by 4 by 3. This can be written as 3 by 2 into 3 by 4. So it is going to be 9 by 8. Children, look at here. So there will be a difference. This is a refractive index of water with respect to glass, whereas this is refractive index of glass with respect to water. So this is how actually we can calculate the relative refractive index. Okay, fine. And children, now we are going to discuss very important. What is that? We are going to discuss about the factors on which refractive index depend. Most wanted. Children, when you can understand these factors, next you are going to understand even the applications of total internal reflection. Their mirage will be there. So the mirage concept is well understood when you know the relation between refractive index and temperature. That is what? Temperature is one of the important factors which affect the refractive index. Now let us see the children. So here, refractive index depends on the following factors. The first one, children, it is nature of the medium. Children, it is a nature of the medium. The refractive index depends on the nature of the medium. Let us see the example. Let us take air. Children, what is the refractive index value? Is mu is equal to 1. What about glass? Glass, the refractive index is equal to 1.5. So the refractive index is different. Then obviously what happens, the speed of the light also differs. So in this, the speed of the light is 3 into 10 power 8 meter per second, and it is what we can say, it is 2 into 10 power 8 meter per second. So it is rarer medium, it is denser medium. Means here the optical density is different here. Optical density is different. Means different mediums will have different refractive index values, due to which what will happen? They behave like different mediums. They behave like a different medium. So this is the first factor, means nature of the medium also very important. Now come to the second factor, that is the physical conditions. So physical condition, here mainly we'll discuss about temperature, physical condition, teacher. So even you can write in exam physical conditions or you can write temperature, very important. Temperature. So dear children, refractive index is inversely proportional to the temperature. Refractive index is inversely proportional to the temperature. That is what, if temperature of the medium increases, then the refractive index decreases. Dear children, during the summer, for example, let us take it is the earth surface. So we know that here atmosphere is with the different layers. So no doubt about it, children, the layers of the air which is near to the earth surface, so temperature is more. So it will be high temperature here. But whereas here it is low temperature, it will be low temperature. That's what will happen, dear children. The refractive index of this here, it will be low. Mu is low here. Whereas here mu is high. Means what? By changing the temperature, as the temperature is changing, dear children, the refractive index also changes. That's what, dear children, the different layers of the atmosphere acts like a different mediums for light. What is the reason? Because mu value is changing. Why mu value is changing? Because the temperature is changing. How? Inversely proportional. When temperature increases, mu value decreases. Now, the third point, very important, wavelength of the light used. Wavelength, or you can say color of the light also. Color of light, that is lambda. Children, here refractive index is inversely proportional to the wavelength. Means more the wavelength, less the refractive index. Less the wavelength, more the refractive index. Children, we know that the wavelength of the red color is greater than that of the violet color. Which means what? Among VIBGYOR colors we are talking, the red color has a more wavelength, violet color has a less wavelength. That's what, children, the refractive index of red color is less than that of the refractive index of the violet color. So very important. This question is very important. In exam, it's a direct question it is. So which color will have more refractive index, or they will ask you which color will have less refractive index. Children, red color will have less refractive index. What is the reason? Because it has a more wavelength. Whereas violet color will have more refractive index. What is the reason? Because it has less wavelength. So these are the factors on which refractive index depends. So children, so these are the topics today which we have discussed. Let us recall once again, children. Children, once again I am going to say, if you want to understand what actually refraction, you must understand the difference between physical density and optical density. So you should understand what actually rarer medium, what actually denser medium. So children, beginning we discussed about the denser medium, rarer medium. Then we discussed what actually refraction of light, cause of refraction, and a no refraction case which we discussed. Then we discussed loss of refraction. That very important thing is that Snell's law of refraction is very important. That is mu is equal to sin I by sin R. Then we discussed absolute refractive index. Then relative refractive index we discussed, and finally we discussed the factors on which actually refractive index depends. Children, in the next session of the refraction of light chapter, we are going to discuss about very important only two topics which we have. That is principle of reversibility, and even we are going to discuss about how refraction can occur through the glass slab. Okay, children, thank you so much. All the very best.